fan in the fan coil can be considered air conditioning for the purposes of National Electrical Code Table 220.84. The definition of air conditioning in the National Electrical Code is the process of treating air to control simultaneously its temperature, humidity, and purity. The fan coil system, which circulates air over hot and cold water coils, meets this definition by controlling the temperature of the air in the dwelling unit. The fact that the heating and cooling source, the boiler and chiller, are common to all dwelling units and fed from the main switchgear is not relevant to the question of whether or not the dwelling units have air conditioning. The National Electrical Code does not specify that the air conditioning system must be powered from the dwelling unit panel. Therefore, if all three provisions of Table 220.84 are met, the optional calculation demand factors can be used for a multi-unit residential dwelling project. This explanation is based on the National Electrical Code definition and its application to a specific system. Let's delve deeper into the specifics of Table 220.84 and its provisions. Firstly, the table is designed for optional calculation demand factors for 3 or more multifamily dwelling units. This means it's applicable when you have a building with at least 3 individual living spaces. Secondly, a key requirement for using this table is that no dwelling unit is supplied by more than one feeder. This ensures that each unit's electrical load is isolated and can be accurately calculated. Thirdly, each dwelling unit must be equipped with electric cooking equipment or air conditioning. In this context, the question arises whether a fan coil unit qualifies as air conditioning. The National Electrical Code defines air conditioning as the process of treating air to control simultaneously its temperature, humidity, and purity. A fan coil unit, even if it only consists of a fan and hot and cold water coils, can be considered air conditioning if it effectively controls the temperature of the air within the dwelling unit. The source of the heating and cooling, whether it's a central boiler and chiller plant, is irrelevant to this determination. What matters is that the fan coil unit provides temperature control within the unit. To further clarify, let's consider the components of a typical fan coil system. The system includes a fan, which circulates air, a filter to remove dust and particles, and hot and cold water coils. These coils are connected to a central heating and cooling plant, which provides the hot and chilled water. The fan coil unit acts as a local air handler, drawing air from the room, passing it through the filter, and then over the hot or cold water coils to adjust the temperature before returning it to the room. Now let's address the common misconception that air conditioning requires a self-contained unit, such as a heat pump or a window air conditioner. The National Electrical Code does not mandate that the air conditioning system be powered directly from the dwelling unit panel. The key is that the system provides temperature control, regardless of the power source. In the case of a central heating and cooling plant, the main power supply is at the switchgear, but the fan coil units still function as air conditioning within each dwelling unit. It's important to consult with local electrical inspectors and authorities having jurisdiction to confirm their interpretation of the code and its application to specific installations. They can provide guidance based on local amendments and interpretations of the National Electrical Code. In summary, when evaluating whether a fan coil unit qualifies as air conditioning for the purpose of Table 220.84, focus on its ability to control the temperature within the dwelling unit. The source of heating and cooling and the power supply location are not the determining factors. As long as the fan coil unit meets the definition of air conditioning by controlling temperature, humidity, and purity, it satisfies the requirement of Table 220.84. Now let's look at calculating the demand factors. When applying Table 220.84, it's essential to follow the specific instructions and percentages provided in the table. The table provides demand factors based on the number of dwelling units in the building. These factors are applied to the total calculated load of the dwelling units to determine the overall demand load for the building. To accurately calculate the demand load, you need to determine the total connected load of all the dwelling units. This includes the lighting, receptacles, appliances, cooking equipment, and air conditioning loads. Once you have the total connected load, you can apply the appropriate demand factors from Table 220.84. The demand factors typically decrease as the number of dwelling units increases. This reflects the fact that not all units will be operating at their maximum load simultaneously. The demand factors are expressed as percentages. To apply the demand factor, multiply the total connected load by the demand factor percentage. The result is the demand load for the building. For example, if you have a building with 20 dwelling units and the total connected load is 100,000 volt amps, and the demand factor from table 220.84 is 40%, the demand load would be 40,000 volt amps. It's important to note that table 220.84 is an optional calculation method. There is also a standard calculation method outlined in the National Electrical Code. The standard calculation method typically results in a higher demand load than the optional calculation method. The choice between the two methods depends on the specific project requirements and the local regulations. The optional calculation method is typically used when it results in a low demand load, which can reduce the size of the service equipment and feeders. However, it's essential to ensure that the optional calculation method is permitted by the local authorities having jurisdiction. Now let's consider some additional factors that can affect the demand load calculation. Firstly, the type of appliances and equipment installed in the dwelling units can significantly impact the load. High-demand appliances, such as electric ranges, clothes dryers, and air conditioners, will increase the overall load. Secondly, the diversity of the loads can also affect the demand factor. If the loads are highly diverse, meaning that they are not all used simultaneously, the demand factor will be lower. For example, if some dwelling units have electric ranges and others have gas ranges, the diversity of the cooking load will be higher. Thirdly, the occupancy patterns of the dwelling units can also affect the demand factor. If the units are occupied by different types of tenants with varying lifestyles, the demand factor may be lower. For example, if some units are occupied by single individuals who are away at work during the day, while others are occupied by families who are home more often, the diversity of the load will be higher. In addition to table 220.84, there are other tables and sections in the National Electrical Code that can be used to calculate demand factors for specific types of loads. For example, table 220.55 provides demand factors for household cooking appliances. It's essential to consult all applicable tables and sections of the National Electrical Code to ensure that the demand load is accurately calculated. In conclusion, when calculating the demand load for a multi-unit residential dwelling project, it's crucial to understand the requirements and provisions of table 220.84. Ensure that you meet all the conditions for using the table, including the type of HVAC system installed in the dwelling units. Accurately calculate the total connected load of all the dwelling units and apply the appropriate demand factors from the table. Consider additional factors that can affect the demand load, such as the type of appliances, the diversity of the loads, and the occupancy patterns. Consult with local electrical inspectors and authorities having jurisdiction to ensure that your calculations comply with local regulations. By following these guidelines, you can accurately calculate the demand load for your project and ensure the safety and reliability of the electrical system. Let's further elaborate on the specific requirements for electric cooking equipment in dwelling units as it pertains to the application of Table 220.84. The National Electrical Code requires that each dwelling unit be equipped with electric cooking equipment or air conditioning to be eligible for the optional calculation method. The electric cooking equipment typically includes electric ranges, cooktops, and ovens. The presence of electric cooking equipment significantly contributes to the overall electrical load of the dwelling unit, and therefore it's a key factor in determining the demand load for the building. If a dwelling unit is not equipped with electric cooking equipment, it may not be eligible for the optional calculation method. In such cases, the standard calculation method may be required. The standard calculation method typically results in a higher demand load, as it does not take into account the diversity of the cooking loads. However, if the dwelling unit is equipped with air conditioning, it can still be eligible for the optional calculation method, even if it does not have electric cooking equipment. In some cases, a dwelling unit may have both electric cooking equipment and air conditioning. In such cases, the total load of both the cooking equipment and the air conditioning system must be included in the calculation. It's important to accurately determine the load of the electric cooking equipment. The National Electrical Code provides tables and guidelines for calculating the load of electric ranges and cooktops. The load is typically based on the rating of the appliance in volt amps or kilowatts. The load of the electric cooking equipment must be added to the other loads in the dwelling unit, such as lighting receptacles and other appliances, to determine the total connected load. Now, let's consider the case where a dwelling unit has a combination of electric and gas cooking equipment. For example, the unit may have a gas cooktop and an electric oven. In such cases, the electric oven would be considered electric cooking equipment for the purpose of Table 220.84. The load of the electric oven must be included in the calculation, while the load of the gas cooktop is not considered. It's essential to carefully review the specifications of the cooking equipment to determine whether it qualifies as electric cooking equipment under the National Electrical Code. If there is any doubt, it's best to consult with a qualified electrical engineer or inspector. In summary, when determining whether a dwelling unit meets the requirements for electric cooking equipment under Table 220.84, ensure that the unit is equipped with electric ranges cooktops or ovens. Accurately determine the load of the electric cooking equipment and include it in the total connected load calculation. If the unit has a combination of electric and gas cooking equipment, only the load of the electric equipment is considered. Consult with a qualified electrical engineer or inspector if you have any questions or concerns. By following these guidelines, you can accurately determine whether your project meets the requirements for electric cooking equipment and can be eligible for the optional calculation method. Now let's discuss the specific requirements for air conditioning in dwelling units as they relate to Table 220.84. The National Electrical Code defines air conditioning as the process of treating air to control simultaneously its temperature, humidity, and purity. This definition is broad and encompasses various types of air conditioning systems. As we discussed earlier, a fan coil unit can be considered air conditioning if it meets this definition. However, there are some specific requirements that must be met. Firstly, the air conditioning system must be capable of controlling the temperature of the air in the dwelling unit. This means that it must be able to both cool and heat the air, depending on the season. A simple ventilation system that only circulates air without controlling its temperature would not be considered air conditioning. Secondly, the air conditioning system must be capable of controlling the humidity of the air in the dwelling unit. This means that it must be able to remove moisture from the air in the summer and add moisture to the air in the winter. Some air conditioning systems may only provide limited humidity control, while others may provide more precise control. Thirdly, the air conditioning system must be capable of purifying the air in the dwelling unit. This means that it must be able to remove dust, pollen, and other contaminants from the air. Most air conditioning systems include air filters that perform this function. The air filters must be properly maintained to ensure that they are effectively removing contaminants. In addition to these specific requirements, the air conditioning system must also be installed and maintained in accordance with the National Electrical Code and other applicable codes and standards. This includes proper wiring, grounding, and overcurrent protection. The air conditioning system must also be properly sized to meet the cooling and heating needs of the dwelling unit. An undersized system may not be able to effectively control the temperature and humidity of the air, while an oversized system may be inefficient and costly to operate. It's important to consult with a qualified HVAC contractor to ensure that the air conditioning system is properly sized and installed. Now, let's consider the case where a dwelling unit has multiple air conditioning systems. For example, the unit may have a central air conditioning system and a window air conditioner in one room. In such cases, all of the air conditioning systems must be considered when determining whether the unit meets the requirements of Table 220.84. The total load of all the air conditioning systems must be included in a calculation. It's also important to ensure that all of the air conditioning systems are properly maintained and are operating efficiently. In summary, when determining whether a dwelling unit meets the requirements for air conditioning under Table 220.84, ensure that the system meets the National Electrical Code definition of air conditioning. Verify that the system is capable of controlling the temperature, humidity, and purity of the air in the dwelling unit. Ensure that the system is properly installed, maintained, and sized to meet the cooling and heating needs of the unit. Consider all air conditioning systems in the unit when determining the total load. Consult with a qualified HVAC contractor if you have any questions or concerns. By following these guidelines, you can accurately determine whether your project meets the requirements for air conditioning and can be eligible for the optional calculation method. Let's delve into the importance of consulting with local electrical inspectors and authorities having jurisdiction when applying Table 220.84. The National Electrical Code is a widely adopted standard for electrical safety, but it is not a law. It is up to local jurisdictions to adopt and enforce the National Electrical Code. Local jurisdictions may also make amendments to the National Electrical Code to address specific local conditions or concerns. These amendments can vary significantly from one jurisdiction to another. Therefore, it is essential to consult with local electrical inspectors and authorities having jurisdiction to ensure that your project complies with all applicable codes and regulations. These authorities can provide guidance on the specific requirements for your area and can answer any questions you may have about the National Electrical Code. They can also provide interpretations of the code and can help you resolve any conflicts or ambiguities. Consulting with local authorities can help you avoid costly mistakes and delays. It can also help you ensure that your project is safe and compliant. The process of consulting with local authorities typically involves submitting plans and specifications for your project for review and approval. The authorities will review your plans to ensure that they comply with all applicable codes and regulations. They may also conduct inspections of your project during construction to ensure that the work is being done properly. It's important to establish a good working relationship with local authorities. This can help you navigate the permitting process more smoothly and can help you resolve any issues that may arise. Be respectful and cooperative, and be prepared to provide all the information they need to review your project. In addition to consulting with local electrical inspectors and authorities having jurisdiction, it's also important to consult with other qualified professionals, such as electrical engineers and HVAC contractors. These professionals can provide expert advice and guidance on the design and installation of your electrical and mechanical systems. They can also help you ensure that your project is safe, efficient, and compliant. In summary, when applying Table 220.84, always consult with local electrical inspectors and authorities having jurisdiction. Understand the specific requirements for your area and comply with all applicable codes and regulations. Establish a good working relationship with local authorities and be prepared to provide all the information they need to review your project. Consult with other qualified professionals such as electrical engineers and HVAC contractors to ensure that your project is safe, efficient, and compliant. By following these guidelines, you can help ensure the success of your project and avoid costly mistakes and delays. And finally, let's discuss some common mistakes to avoid when applying Table 220.84. One common mistake is failing to meet all the requirements for using the table. As we have discussed, the table has specific requirements for the type of dwelling units, the type of cooking equipment, and the type of air conditioning systems. If you do not meet all of these requirements, you cannot use the table. Another common mistake is miscalculating the total connected load of the dwelling units. The total connected load is the sum of all the electrical loads in the dwelling units, including lighting, receptacles, appliances, cooking equipment, and air conditioning systems. If you miscalculate the total connected load, your demand load calculation will be inaccurate. Another common mistake is using the wrong demand factors from the table. The demand factors vary depending on the number of dwelling units in the building. If you use the wrong demand factors, your demand load calculation will be inaccurate. Another common mistake is failing to consider other applicable codes and standards. Table 220.84 is just one part of the National Electrical Code. There are many other codes and standards that may apply to your project, such as the International Building Code and the International Mechanical Code. You must comply with all applicable codes and standards to ensure that your project is safe and compliant. Another common mistake is failing to consult with local electrical inspectors and authorities having jurisdiction. As we have discussed, local jurisdictions may have specific requirements that differ from the National Electrical Code. You must consult with local authorities to ensure that your project complies with all applicable codes and regulations. Another common mistake is failing to properly document your calculations. You should keep a record of all your calculations, including the total connected load, the demand factors, and the demand load. This documentation will be helpful if you are ever asked to justify your calculations. In summary, when applying Table 220.84, avoid these common mistakes. Ensure that you meet all the requirements for using the table. Accurately calculate the total connected load of the dwelling units. Use the correct demand factors from the table. Consider all other applicable codes and standards. Consult with local electrical inspectors and authorities having jurisdiction. Properly document your calculations. By avoiding these common mistakes, you can ensure that your demand load calculation is accurate and that your project is safe and compliant.